Good day to our lecturers. So we from Group 10 and today we are excited to present our hands-on project for electrical machine about a DC generator. Moving on to the construction of our DC generator, we began the design process digitally by using a Tinkercad to map out and create our 3D model for 3D printer. This allows us to visualize the exact alignment and specific measurement for all of the components before physical assembly. Our rotor feature an open coil winding configuration split into two independent halves. For the winding, we wrap a total of 10 coils to optimize the electromagnetic induction process. We place two magnets on opposite side to establish and concentrate a powerful magnetic field across the armature. By combining this specific parameter, we achieve the exactly physical configuration required to efficiently convert our mechanical rotation into electrical energy.
Now, I would like to explain about the working principle of our generator and how it converts mechanical energy into electrical energy. So, our generator mainly consists of the shaft, rotor with permanent magnet, stator with copper winding, bearing, and also the outer housing, as shown in the figure of the 3D model in the slide. The energy conversion process begins when the mechanical energy is applied to the shaft, and it will cause the shaft and the rotor rotate together. One of the unique features of our design is that the rotor winding is divided into two completely independent halves, forming an open coil lap winding configuration. It called lap winding because each coil is connected to the adjacent commutator segment rather than jumping across the rotor as in the wave winding. It also called open coil design because two winding halves is not connected together, unlike the conventional closed loop winding. This design simplify the internal wiring, reduce the unwanted circulating current, and make maintenance and troubleshooting much more easier. As the rotor spin, the permanent magnet create a rotating magnetic field around the stator.
So the stator remains stationary and contains copper wire winding surrounding the rotor. As the rotor rotates, the magnetic field continuously passes through this winding, causing the magnetic flux to change. According to Faraday's law of electromagnetic induction, a changing magnetic field induces an electromotive force or EMF in the stator coils. The EMF causes electrons to flow through the winding, producing an alternating current AC. Although the two rotor winding halves are electrically independent, they are interact through the carbon brushes, which act as the electrical interface as the commutator rotate beneath two brushes. The brushes collect the generate current and combine the output from both winding halves to deliver power to the external circuit. The output voltage depends on factors such as the rotational speeds, magnet strength, and number of coil turns. In general, increasing the rotor speed producing a higher output voltage. In summary, our generator convert mechanical energy into electrical energy through electromagnetic induction. The rotating magnetic field induce voltage in the stator winding, and the generate electrical energy is collected through the brush and commutator system before being supplied to the external load.
Okay, first we have bearing. Its main function is to support the rotating shaft and reduce friction between the moving shaft and the stationary housing. This allows the shaft to rotate smoothly and keeps the rotor properly aligned. The advantage of using bearings is that they improve the generator's efficiency by reducing energy loss, minimize wear on the moving parts, and increase the overall lifespan of the generator. Okay, move on to the second part, which is shaft. Shaft function is to transfer mechanical energy from the external source, such as the footstep mechanism, to the armature, causing it to rotate. It also supports all of the rotating components and keeps them aligned during operation. The advantages of the shaft are its high mechanical strength, efficient power transmission, and ability to provide stable and reliable rotation. And for the third part, we have armature. This is armature, which is the rotating component of the DC generator. Its function is to rotate inside the magnetic field produced by the neodymium magnet. As it rotates, an electromotive force or EMF is induced in the armature windings through Faraday's law of electromagnetic induction and generate the electrical energy. The advantages of the armature are its efficient conversion of mechanical energy into electrical energy, stable power generation, and ability to operate continuously under load. And then we have neodymium magnets. Its main function is to produce a strong and constant magnetic field inside the DC generator. As the armature rotates through this magnetic field, an electromotive force or EMF is induced in the armature windings according to Faraday's law of electromagnetic induction that generate the electricity. The advantages of using neodymium magnets are their higher magnetic strength, which increases the generator's efficiency and output voltage. They also do not require an external power supply to create the magnetic field, making the generator more compact, energy efficient, and reliable.
My name is Muhammad Hilmi Haris. So I will continue for the commuter. So as the motor turns, this part acts like a switch. So it can flipping the direction of the electricity back and forth. And then this is perfectly timed with the magnetic push and pull, which keeps the motor spinning smoothly in one direction. So for the advantage, it produces DC output without requiring an external rectifier, ensures a continuous and usable DC current. And then for the spring, there is small spring sitting right behind every carbon brush. So its only job is to constantly push the brush forward. It make sure that the brush is always precisely tightly against the spinning commutator so the electric connections never breaks. So the advantage for the spring is to maintain reliable electrical contact and then compensates automatically as the carbon brush wears down, and then lastly reduce electrical sparking and contact resistance. And for the carbon contact brush, the brush stands completely still in the middle of the commutator, and then it acts like a bridge for the electricity. So the power goes from your battery and then travels through this steel brush and goes right into the spinning commutator that is touching, just like in the picture that beside. And then the advantage for this function is good electrical conductivity, and then low frictions against the commutator, and lastly self-lubricating, reducing wear on the commutator. Okay, that's all from me. Thank you.
Okay, now I will present the industrial applications of DC generators. So a DC generator converts mechanical energy into a direct current electrical energy through electromagnetic induction. Although AC generators are more widely used today, DC generators are still important in applications that require a stable DC power supply. As shown in the table, DC generators are commonly used for battery charging, DC welding machines, and also backup power systems. In each application use DC generators because they provide a very reliable and continuous direct current for its specific purpose. So this is the DC generator that our group designed and assembled. So it is built using amateur neodymium magnets, 9 mm steel shaft and bearings. So even though our generator is a simplified prototype, it demonstrates the same fundamental principle used in industrial DC generators, which is we call it electromagnetic induction. So when the shaft rotates, the armature moves within the magnetic field created by the magnets. so inducing a voltage and producing a DC output. So this project allows us to understand how mechanical energy is converted into electrical energy using a simple and a very practical design.
So this is our motor.
We made it so that you can see the coils and then the magnets are also visible. So inside it consists of a spring and carbon brush commutator. It has 10 arms, so 10 commutator connections, and it also is a it is also a lap winding, so as to increase the current for this particular generator. Let me now demonstrate its generation capabilities from these two output pins. Now to demonstrate the demonstration, we have it hooked to this pole and hook that pole towards a drill so it could rotate and get our readings. Ready? Coba. Okay. 3, 2, 1. Okay,